Hello, today we're going to be discussing Etherchannel Operations. This is an important piece of network design that is primarily used in redundancy and port link aggregation. My name is Daniel and I'm a student of computer networking. My interests are in learning about the latest up-to-date technologies, and I have recently become interested in the cloud. One of my hobbies include enjoying the outdoors. Of those activities are hiking and sightseeing. Currently, I'm an intern at Virtually Testing, learning more about computer networks in general. In our agenda today, we're going to first be answering the question of what is Etherchannel, how did it originate, and its purpose and importance in the network. Next, we will describe the two main protocols used to implement Etherchannel, which is PAGP and LACP. We will define what it is and which one is better for what type of networks. Finally, we will discuss Etherchannel packet tracer activity and how we will go about designing it. Let us begin with Etherchannel. We will discuss about its origins and how it came about. Then we will define it. And lastly, we will talk about link aggregation, which will shift us into the topic of two sub-protocols of PAGP and LACP. On to Etherchannel Origins. It was first developed by a Kaplana employee of Scott Childs in 1990s. It was then acquired by Cisco Systems in 1994 for the LAN-to-switch usage. Mainly used in the backbone of networks, it played a crucial role in connecting end-user machines. Overall, its main importance and reason behind its creation is for network fault tolerance and redundancy. Let's now define Etherchannel more in depth. Etherchannel is a link aggregation technology that allows for redundant links. It allows for multiple physical Ethernet links to combine into one logical channel. This is important because the spanning tree protocol automatically blocks redundant links in layer 2 switches, and Etherchannels allow us to get around that barrier. With Etherchannel, it has benefits in providing fault tolerance, load sharing, and increased bandwidth. With that, Etherchannel comes in two protocols, PAGP and LACP. Here we will discuss the difference between PAGP and LACP. First, we will define the protocol, then talk about the modes on which they operate, and finally compare what makes them different from each other. Port Aggregation Protocol, most known as PAGP, is a Cisco proprietary protocol that helps in the creation of Etherchannel links. When the channel is configured by PAGP, the packets are sent between the ports to negotiate a channel. After the channel is formed, PAGP is used to manage the Etherchannel, where it sends packets every 30 seconds to check the links to ensure there is no failure between the two end switches or devices. There are three modes in PAGP: on, desirable, and auto. The on mode will force the interface to channel without PAGP. Then there is desirable, which puts the state in active negotiating. Here it will send other interfaces the PAGP packets to begin initiation. Lastly, there is auto, which puts the states in passive negotiating. Here, there will be no initiation of the PAGP with other packets. This is the table of the modes. On switch 1 and switch 2, you see that if the two ons, then the channel channel is yes. And if you see on in desirable and auto, it's no. Two desirables is yes. One auto and desirable is yes. Two autos is no. Next is Link Aggregation Control Protocol, known as LACP. LACP is basically the same as PAGP, but it is open source to use on any devices, meaning it is open vendor neutral. Originally, LACP was IEEE 802.3AD, but now the newer version is 802.1AX for the local and metropolitan areas. The three modes are the same as PAGP's, but just named differently. On is still named on, the desire mode is named active, and the auto mode is now named passive. This is the same chart from PAGP, but with the name just switched. Now, a quick recap of the two Etherchannel protocols. PAGP and LACP are both port link aggregation protocols that allows a high-speed, fault-tolerant links between switches, routers, and servers. PAGP is Cisco's proprietary, as LACP is open standard and vendor neutral. PAGP has only Etherchannel, as to LACP has Etherchannel and the IEEE 802.1ax standard. And lastly, PAGP has the auto and desirable modes, whereas LACP has passive and active modes. Now onto the Etherchannel packet tracer activity exercise. I will first show you a picture of the design, then describe the graph that we will be following during the activity. Here is a lot to absorb, but let's begin from the bottom up. We see that there are 3 PCs, each will be on their own network. Then as you move up, there are 3 switches, each connection to their own PCs. Each switch connects with the other switches in 2 ether channels each. Each ether channel has 3 ports allocated to it. Then we see each switch connecting to the first multilayer switch and to the second multilayer switch. These will be doing most of the routing. Between the multilayer switches, there are redundancy 2 network protocols for the HSRP configuration. HSRP is not covered and will be in another video. This is just getting into more network redundancy for layer 3. Then, from the multilayer switch to the router, we will connect to the public internet. This is the chart we'll be referring to as we go through the packet tracer activity. I will leave a PDF copy in the description below. Some points to cover are that the default gateway ends with the .254 and the secondary gateway ends with the .253. For both Etherchannel and SRP groups, each will be matched with the VLAN numbers. And for all the virtual gateways, it ends with the .250. Mostly VLAN on multilayer switch 0 will be the active gateway with the priority of 150 that overlaps the multilayer switch 2 that has the default priority of 100. To finally recap, what we did today was talk about the network redundancy between networking devices. We first began with Etherchannel and talked about its origins and purposes in the network for redundancy between switches. Then we went on to protocols of the Etherchannel, which we described the PAGP, a Cisco proprietary, and LACP, the newer and preferred protocol for configuring Etherchannel groups. I finally ended with a small introduction that I will demonstrate on the next video from my next packet tracer lab. Thanks for watching. I'll see you in the next video to demonstrate a hands-on activity.